All right, good afternoon, everyone. We will get started in just a moment. Uh, we will be recording this session. If all other microphones are off, I just want to remind everyone that we are recording. And let's get started with Module 1. So my name is Manesh Patel. I'm an environmental engineer within the Division of Watershed Protection and Restoration. I'd like to welcome you to the latest Stormwater Management Design Review course. Each module will have a moderator, and today that is Changyi Wu. Staff will be presenting as a 4-part course the key elements of the Stormwater Management Design Review process in order to assist you in complying with the stormwater management rules that are found at NJAC 7:8 and as required by the Municipal Separate Storm Sewer System permits, or MS4 permits. We are presenting this course fully online via Microsoft Teams. So before I present the course agenda, I would like to go over a few course rules. I would like to give notice that this module and the other subsequent modules will be video recorded. The videos will be posted on YouTube and links will be included on the Stormwater Management webpage for future reference. A web link to our webpage was emailed to you in the invite, which will bring you to our PowerPoint slides of each presentation. And they will also remain available on the webpage for some time to be reviewed and are downloaded for future reference. In order to receive a certificate of completion and the certificate of the Professional Engineers Continuing Professional Competency Credits, or CPCs for short, you'll need to complete all 4 modules, which would include completing all 4 quizzes. If you don't complete all 4 modules in this training session, you will need to make up the missing module in the next training session before we can issue you the certificate of completion and the certificate of CPCs. The schedule is compressed from our classroom setting, so we will move along at a brisk pace with short 1 to 2 minute breaks between the individual presentations. Although we are allowing time for questions at the end of each presentation, if you could please use the chat function for each meeting to enter your questions as we go along. We will be reviewing the chat as we go along and plan to answer the more general type of questions during the presentations. However, more individualized and site-specific questions will need to be addressed offline after the class. Also, with so many people online, for this training, enrollee microphones will be muted, but we can unmute if you do want to ask a question verbally. And lastly, as I mentioned earlier, there will be an online quiz at the end of each module that you will have around 10 to 15 minutes to complete. You must take the quiz during the time allotted, and you cannot go back after that time has ended. This is in part a tracking mechanism in order to provide credit for the course. And after each quiz, we will present the correct answers in our quiz review. So please try your best so that we can grade ourselves on how well we've covered the material. If you are not able to download the slides from the link in the email, they can still be accessed under this website, which will be pasted in the chat by staff. You may want to keep this open in a separate tab or window, and take note that these are the newest slides and will look a little different from those on the public-facing page. That is the one where the completion listings are posted. These slides will eventually replace those older ones once we process the videos we're making for today and the subsequent modules. Here's a snapshot of what the handouts page for this edition of the class will look like. You can download the slides for each presentation and each module. The links are embedded in each blue box, so you can just click that box to whatever matches whichever presentation you would like to view. And now this brings us to our agenda for the course. So the agenda for Module 1 will begin with Lisa, who will provide the introduction and the federal background. Peter Pliantos will then present the stormwater overview of basic concepts and terms. You will then hear from me on maintenance requirements. And then Dr. McGee from NJCAT will present on manufactured treatment devices. Each of the modules includes a quiz to be taken online during the time allotted. We will then close the quiz and review the quiz questions. We will be providing links and QR codes to the quizzes in the chat and on the slides. It is suggested you use your cell phone cameras, focusing on the QR code that will be shown on the screen, and that will take you to the quiz on SurveyMonkey. If you're going to be taking the quiz on your computer, be sure to open the quiz link in a new window or tab so you can also remain in Microsoft Teams. And now for Module 2, which will be Thursday. We'll start with Peter Pliantos, who will present the stormwater calculations. And then Lisa Schaefer will then present the soil testing criteria, as well as information about the green infrastructure fact sheet. And then we will administer our second quiz of the session immediately afterwards. Module 3 for Tuesday, April 21st. We'll start with a presentation called How to Review a Project, Part 1, which will be presented by Peter Pliantos along with myself. And then Lisa Schaefer will be presenting Part 2. And then lastly, Module 4 will take place on April 23rd with presentations on groundwater mounding, the NJ Pact rule amendments, and some GI plan examples, along with an overview of the municipal stormwater program. After these 4 presentations, we will then administer Quiz 4. One very important reminder before we start. After class is over, we will be emailing out a link to an evaluation survey only to those who had completed all 4 modules, which would include all of the quizzes. We are required to collect an evaluation in order to issue continuing education credits. Only after you submit your evaluation survey, you will be sent your certificate of completion and our PE credits once staff creates them. And that should hopefully occur about 2 to 4 weeks after the class has finished. So with that being said, we will start with the introductory history lesson and basics of the permits. So please stand by while we switch over to Lisa.
Good afternoon, everyone. So I'm Lisa Schaefer, and welcome to SWMDR. I'll be providing you today with a brief history of the federal basis for the Municipal Stormwater Regulation Program, as well as a brief introduction to some of the permit requirements that you will hear about during the training. So please save your questions for the end of the presentation, or if you'd like, you could enter them into the chat. So let's get started. Shown here are some of the terms we frequently use in our stormwater program, and this presentation will provide an overview of the history of these words and how they are part of the program. So to begin, we'll look back almost 80 years ago. The Federal Water Pollution Control Act of 1948, also known as FWPCA, cleared the way because it was the first major U.S. law to address water pollution, and it authorized the Surgeon General to prepare comprehensive programs for reducing the pollution of interstate waters. It also authorized the Federal Works Administrator to prevent discharges of inadequately treated sewage and other wastes into interstate waters and tributaries. And this is because over the years, our rivers have become increasingly more polluted with sewage, oil, debris, and other chemicals. All right, so now let's fast forward about 20 years to Cleveland, Ohio. The Cuyahoga River runs north through the heart of Cleveland towards Lake Erie and was an historical shipping route. At the time, Cleveland was emerging as a major center for manufacturing, and because of this, the river became heavily affected by industrial pollution to the point that it was covered with oil and debris. And on June 22nd, 1969, sparks from a passing train were all it took to start a fire. It was reported that these flames reached up to 5 stories in height. Now, this wasn't the first time it happened, as there were more than a dozen fires over the years before. However, this was the event that sparked people's attention. A few months later, just a few months later, the National Environmental Policy Act, aka NEPA, was signed into law on January 1st, 1970, creating the U.S. Environmental Protection Agency. In 1972, amendments were made to the Federal Water Pollution Control Act, the one from 1948, with the resulting legislation becoming known as the Clean Water Act. It's in Section 402 of this act that the National Pollutant Discharge Elimination System, NPDES or NPDES program, was created, and it prohibits discharges of pollutants from any point source into the nation's waters except as allowed under a NPDES permit. And it's because of this program that the EPA is authorized to regulate discharges into the nation's waters by setting limits on the effluent that can be introduced into a body of water from an operating and permitted facility. NPDES also established requirements for what a state must do to obtain federal approval to implement and operate its own program. And in 1982, New Jersey received federal authorization to implement various NPDES program components, including those for a state pre-treatment program to regulate federal facilities and issue general permits. This program is known today as NJPDES or NJPDES for short. This is the framework through which NJDEP regulates the discharge of pollutants to the surface and groundwaters for the entire state. Now, 1 year later, in 1983, New Jersey proposed and published a new rule establishing effluent limitations for discharges to surface waters of the state and for indirect discharges into domestic treatment works, including discharges resulting from different precipitation events. 4 years later, in 1987, the Water Quality Act was passed, which called for increased monitoring and assessment of water bodies to ensure that water quality standards were being met. Excuse me, just one moment. And in 1990, the EPA published initial permit application requirements for certain categories of stormwater discharges, which was called Phase 1. Nearly a decade later, Phase 2 provisions were published, and they initiated stormwater management requirements for municipalities, public complexes such as your large public colleges, prisons, hospital complexes, and military bases, and also highway agencies such as the county, state, interstate, or federal government agencies that operate highways and other thoroughfares. These provisions covered basic EPA permitting requirements and created a mandate for these entities to develop and implement a program to reduce discharges of pollutants from their respective stormwater systems. These systems are referred to as Municipal Separate Storm Sewer Systems, or MS4s for short. These provisions also covered combined sewer overflows where commingled stormwater and wastewater are discharged, and industrial stormwater discharges where stormwater in contact with industrial pollutants is discharged, each with their own separate set of regulations. The portion of the NJPDES rules pertaining to the Municipal Stormwater Regulation Program is found in subchapter 25 of NJAC 7:14A. In February 2004, these rules were amended, establishing Tier A and Tier B designations for all 557 municipalities in the state of New Jersey that have MS4s. Most municipalities were designated as Tier A, which is generally for the more densely populated municipalities, while the rest were designated as Tier B. However, as of July 2022, all Tier B municipalities were reassigned to Tier A, and are now regulated under the 2023 Tier A permit. The public complex permit authorizes discharges from small MS4s that are owned or operated by a county, state, interstate, or federal agency at a public complex located entirely or partially in a municipality that is assigned to Tier A or in a municipality that receives a waiver. And the highway agency permit authorizes discharges from small MS4s that are owned or operated by a county, state, interstate, or federal agency at a highway or other thoroughfare, including a maintenance or service facility or rest area for such a thoroughfare. The federal program requires that MS4 stormwater programs include 6 minimum control measures. The New Jersey MS4 permits require the same 6 things, except they're called minimum standards, and they're found in Part 4, Sections B through G of the permit. All right, the 6 minimum standards include the following 3. Public involvement and participation, which includes the requirements for public notice. 2, local public education and outreach, which can include labeling storm drains, training on building rain barrels, and other measures to increase public awareness on pollution prevention. 3, construction site stormwater runoff, which requires construction activities to be authorized under the Industrial 5G3 Construction Activities Permit. Okay, so let's move on to the next 3 minimum standards. 4 is post-construction stormwater management in new development and redevelopment, which requires the permittee to develop, update, implement, and enforce a program to address stormwater runoff. This includes the necessary plans and ordinances in keeping with the requirements of the stormwater management rules. Number 5 is pollution prevention and good housekeeping. It includes community-wide ordinances, community-wide pollution prevention measures, best management practices at maintenance yards and ancillary operations, and stormwater training requirements. Number 6 is the MS4 mapping and scouring and illicit discharge detection and elimination. That includes mapping the MS4 infrastructure stormwater features, controlling localized stream scouring, and tracking down and eliminating illicit discharges of pollutants. So, in addition to ensuring compliance with all 6 minimum standards in Part 4, Sections B through G, the MS4 permit requires the permittee to incorporate into its stormwater management program any requirements for additional measures that are identified by the state as required of a permittee, and optional measures such as BMPs that extend beyond the requirements of the permit to further prevent or reduce pollution to state waters. So for more details on these, you would look in your permit in Part 4, Section I. So looking more closely at the 4th minimum standard that we talked about just a few slides ago, the permittee is required to develop, update, implement, and enforce a stormwater management program. And the purpose of this stormwater management program is to address the negative impacts caused by development, some of which are listed on this slide, and they will be covered in more detail in the next presentation. This program is what designers must follow for projects over a certain threshold in size. So to be clear, federal regulations require that these impacts be addressed, and New Jersey is authorized to issue permits with these same requirements. So therefore, the responsibility to review projects under its stormwater management program falls directly on the permittee, who must ensure that these impacts are adequately reduced. Now, this required post-construction stormwater management program must include certain elements. So let's take a look at what those are. Each box on this slide represents a required element of the post-construction program, and there's a bit of an order to these elements. The first box is the Municipal Stormwater Management Plan, which is required under NJAC 7:8, aka the Stormwater Management Rules or the rules in Subchapter 4. Every municipality is required to have a stormwater management plan, which is adopted into the master plan and used for long-term planning. The second box is the Stormwater Control Ordinance, or SCO, which is required under both the Stormwater Management Rules and the Residential Site Improvement Standards, which are found in NJAC 5:21. Every municipality is required to have an SCO, which is the regulatory tool to implement and enforce standards on projects. Those SCOs need periodic updating to align with changes to the rules. Tier A permittees previously had 1 year from their plan adoption date to adopt an SCO and submit all of this to the county review agency for approval. The Stormwater Management Rule amendments adopted on March 2nd, 2020 had a delayed operative date of 1 year so that municipalities could update their SCOs to match the rule amendments by March 2021. And in the case of the Stormwater Rule amendments adopted on July 17, 2023, the municipalities had 1 year to adopt and make effective an SCO that was in accordance with those same rule amendments, meaning by July 2024. Now, for the NJ Pact amendments, the SCO and the MSWMP, Municipal Stormwater Management Plan, must be amended and put into effect by January 29th in the year 2027. So please note that the department has created a model SCO for municipalities to use as a template. So let's take a look at what's in the model before we finish with the remaining elements on this slide. First and foremost, the SCO must include the design and performance standards for stormwater management measures found in subchapter 5 of 7:8, aka the rules. These standards will be covered throughout the rest of the training, and they include the requirement to use green infrastructure, all right, GI, to meet the design and performance standards, which replace the implementation of the 9 non-structural strategies. How compliance with the groundwater recharge requirement is demonstrated, how water quality is to be addressed, and the rainfall distribution for the New Jersey Water Quality Design Storm, how stormwater runoff quantity control may be addressed, including the volumetric reduction standard, how stormwater runoff and groundwater recharge shall be calculated, and the detailed maintenance requirements. The SCO must also address the safety standards found in subchapter 6 of 7:8. All reviewers must follow the SCO. So if you are a municipal consultant, you must know what is in the SCO of each MS4 for whom you review projects. All right, so coming back to the post-construction program requirements, every municipality must then enforce their own SCO, review applications for compliance with their own SCO, and ensure long-term operations of BMPs, which includes making sure the required maintenance is performed, which for municipalities also includes privately owned facilities. The last box also applies to public complexes and highway agencies. Please note that this is not a one and done scenario. It's a cycle because the municipal stormwater plan must be updated periodically. Okay, or that is whatever the master plan is re-examined. So the cycle starts over. Now, at the bottom of this slide, you'll see that it says audit by NJDEP. In 2016, MS4 permitting program began performing compliance assistance audits of municipalities to determine how well they were demonstrating compliance with their permit and where they needed help, whether with language in the SCO, following the SCO, or other permit requirements. But now we're partnering with enforcement in our audits, meaning that the department can now issue a notice of violation, or NOV, for an instance of non-compliance with the permit requirements. Some other consequences of non-compliance, as mentioned before, if you're not following all of the MS4 permit requirements, can lead to an enforcement action by NJDEP. So even if a major development project was previously constructed, it may still not fully comply with the SCO if the reviewer did not conduct a proper review, and the municipality can still be issued an NOV for failure to comply with the post-construction program. EPA can conduct audits as well, and these have historically been very in-depth and very long in the process, and they can result in sizable fines and penalties levied against a permittee in accordance with the Clean Water Act. In fact, some of these past penalties have ranged from 4 figures to millions of dollars, depending on the type of violation. The department would like to prevent this from happening. So this training is designed to show reviewers how to review a project so that the permittee stays in compliance with the permit. That means that the permittee has the authority to ask applicants for revisions in order to enforce and follow its program, as well as the permit and the rules. All right, so to wrap things up, we're here. Hold on, let's see if I can move this. Okay, we're here for reasons dating back to the Clean Water Act. The federal NIPDES program authorized by New Jersey to implement a stormwater permitting program for its municipalities, public complexes, and highway agencies. While the state NIPDES program details what must be done at the local level to eliminate the discharge of pollutants from an MS4 and to implement the required post-construction stormwater management program. This post-construction program also requires municipalities to develop, implement, update, and enforce their SCO, or Stormwater Control Ordinance, and to ensure that long-term maintenance is being performed. There are potential penalties now for non-compliance. Also, I want to mention that this course is a requirement for reviewers under all MS4 permits, and the permittee must make sure each reviewer completes this training once every 5 years. So that's the end of this presentation, and I want to thank you for your attention. Now, if you want to or need to contact the MS4 permitting unit with permit-related questions, the email address is here on the slide. That's the MS4 unit. All right, so I don't know if there are any questions that have not been addressed in the chat.
We don't have questions, so please continue the presentation.
Thank you. All right, so up next is Peter, and he'll discuss the basics of stormwater runoff, the impacts of development, and the rule requirements to mitigate these impacts. Please stand by.
Thanks, Lisa.
You're welcome.
I will share my screen. One moment. All right. Good afternoon. My name is Peter Plantos, and in this presentation, I'll be providing you with a basic understanding of what stormwater is, its interactions with the terrain, and a brief look at the stormwater control measures in place through the Stormwater Management Rule. This presentation is organized into 3 parts. The first part discusses the hydrologic cycle and what impacts land development has on it. Second, we'll introduce some terms relevant to managing stormwater runoff. And the third part will discuss the standards found in the Stormwater Management Rule, NJAC 7:8, to mitigate some of the adverse effects land development has on the hydrologic cycle. We'll begin with land development's impacts on the hydrologic cycle. Since stormwater is the focus of this presentation, let's define it up front. Stormwater is water resulting from precipitation, including rain and snow, that runs off the land surface, is transmitted to the subsurface, or is captured by separate storm sewers or other sewage or drainage facilities, or conveyed by snow removal equipment. So now that we've defined stormwater and what produces it, we'll move on to what can control it. That is, the conditions that increase or reduce runoff. Listed here are some basic site conditions that act as a type of control on stormwater. In many cases, the first point of contact for stormwater is vegetation. Dense vegetation scatters precipitation, making it less likely to coalesce and flow. Rough surfaces also inhibit flow. Steep slopes will have an opposite effect and will increase the velocity of flow. Lastly, the surface material itself and even the underlying layers can affect the amount of runoff produced by a site. Pavement will produce a greater volume of runoff than a grassy field, for example. Next, we'll look a little deeper into the effects each one of these site conditions has on rainfall. Beginning with vegetation. When it rains on a tree, the precipitation falls through the leaves and branches, runs along branches and stems or trunks, and then contacts any other shrubs, bushes, and leaf litter lying on the ground. Some of the moisture that penetrates to the soil can then be taken up through the roots of the plants. The leaves of the plants can also absorb moisture. And release of moisture back to the atmosphere then occurs in a process called evapotranspiration. Next, we'll take a look at soils. The properties of the underlying soils can contribute to stormwater runoff. Movement of water into the pores or voids of soil is called infiltration. The rate of infiltration can vary with soil composition, and for soils comprised predominantly of clay can be almost zero, while as for sands, the rate can be 10 inches per hour or more. When the voids become full of water, the soil becomes saturated. Saturated soils cannot absorb any more water, so there is more runoff. Many of the stormwater practices used on developments are designed based on the assumption the soil is fully saturated, so we can best predict the amount of runoff produced and manage it safely. The condition of surface roughness has an effect on the velocity of stormwater as it flows, with higher surface roughness impeding the velocity. The actual topography also has an effect on the movement of stormwater. Steep slopes shed runoff more quickly than those that are more gradual, and uneven terrain provides opportunities for surface detention and the slowing down of stormwater runoff, as illustrated in this graphic. Putting what we have covered together, we can then discuss the hydrologic cycle. For an undeveloped site, a large portion of the precipitation, represented by the largest arrow on the graphic, supports vegetation, resulting in evapotranspiration or infiltration, which maintains groundwater flow. Typically, there is little runoff and it flows over land to a water body. An equivalent volume of precipitation as to that received by the undeveloped site falls onto the same site post-development. Since the site has considerably more impervious ground coverage as compared to before, there is much less infiltration and therefore depletion of groundwater base flow, as well as slightly less water returning to the atmosphere via evapotranspiration. This site also has a stormwater collection system that discharges to the water body. The insides of stormwater pipes are much smoother than vegetated surfaces, so the higher volume of collected runoff reaches the water body more quickly, potentially causing downstream flooding. Higher rates of runoff can also mean increased erosion and transport of sediment. Development can also cause higher levels of nutrients, like pet waste and fertilizers, pollutants such as vehicle exhaust compounds, pesticides and industrial chemicals, and heavy metals like copper from brake dust. So in summary, the three primary impacts land development has on stormwater and the hydrologic cycle as a whole are increasing the volume and rate of stormwater runoff through an increase in impervious areas with lower roughness coefficients, degrading the quality of downstream water bodies through increased suspended solid concentrations and increased nutrient loadings, and depleted groundwater and stream base flow, which is also due to increased impervious ground coverage. Now we'll move on to the second part of this presentation, where we will define some terms relevant to the stormwater management rule and introduce some basic related information. We'll begin with defining each of the terms on this slide. First is green infrastructure. The stormwater management rules include the requirement to use green infrastructure. This is the definition of green infrastructure as noted under section 1.2 of the rules. Part of this definition specifies that green infrastructure manages stormwater close to its source, which plays an important part in the stormwater management rule. Along with the stormwater management measure being located close to the source of runoff it's designed to receive, green infrastructure must treat the stormwater runoff or store it for reuse. Moving on to the disturbance definition at NJC 7:8 1.2, disturbance means the placement or reconstruction of impervious surface or motor vehicle surface, exposure and or movement of soil or bedrock, or clearing, cutting, or removal of vegetation. And the NJ Pact rules adopted on January 20th, 2026 expand the maintenance activities which are not considered disturbance. So here's the list of maintenance activities not considered disturbance for the purposes of NJC 7:8, some of which are repair or replacement of traffic, utility, and ITS structures on poles, repair or replacement of rail ties or sleepers, geotechnical investigation activities, and the removal of accumulated sediment and debris from a channel. Reconstruction is a new term in the stormwater management rules adopted on January 20th, 2026. Reconstruction means the replacement, rebuilding, or restoration of a lawfully existing structure. The rules define motor vehicles and surfaces on which they are operated as they contribute to pollutants and stormwater runoff. Motor vehicle surface means any pervious or impervious surface that is intended to be used by motor vehicles and or aircraft, and is directly exposed to precipitation, including but not limited to driveways, parking areas, parking garages, roads, racetracks, and runways. And in the next slide, we'll define just exactly what is considered a motor vehicle. Motor vehicle means land vehicles propelled other than by muscular power, such as automobiles, motorcycles, autocycles, and low-speed vehicles. For the purposes of this definition, motor vehicle does not include farm equipment, snowmobiles, all-terrain vehicles, motorized wheelchairs, go-karts, gas buggies, golf carts, ski slope grooming machines, or vehicles that run only on rails or tracks. Building on the definitions from the previous two slides, a regulated motor vehicle surface means any of the following, alone or in combination. 1, a net increase in motor vehicle surface, and or 2, the total area of motor vehicle surface that is currently receiving water quality treatment, either by vegetation or soil, by an existing stormwater management measure, or by treatment at a wastewater treatment plant, where the water quality treatment will be modified or removed. And just to note, areas that are only for emergency use and are regularly gated from motor vehicle traffic may be excluded from a site's total regulated motor vehicle surface. A regulated impervious surface means any of the following, alone or in combination. 1, a net increase of impervious surface. 2, the total area of impervious surface collected by a new stormwater conveyance system. 3, the total area of impervious surface proposed to be newly collected by an existing stormwater conveyance system. And or 4, the total area of impervious surface collected by an existing stormwater conveyance system where the capacity of that conveyance system is increased. Also, note that for the purposes of this definition, a new stormwater conveyance system is a stormwater conveyance system that is constructed where one did not exist immediately prior to its construction, or an existing system for which a new discharge location is created. And this now all comes into play with the next slide, which is the definition of major development. The major development definition has been amended with the January 20th, 2026 Stormwater Management Rules. To start, I'll just read through the slide here. Major development means an individual development, as well as multiple developments that individually or collectively result in 1, the disturbance of one or more acres of land since February 2nd, 2004. 2, the creation of 1/4 acre or more of regulated impervious surface since February 2nd, 2004. 3, the creation of 1/4 acre or more of regulated motor vehicle surface since March 2nd, 2021. 4, the reconstruction of 1/4 acre or more of motor vehicle surface or impervious surface since January 20th, 2026. Or 5, a combination of 2, 3, and 4 above that totals an area of 1/4 acre or more. The same surface shall not be counted twice when determining if the combination area equals 1/4 acre or more. And so I would like to emphasize a couple points in relation to the amendments. For number 1, the text has not changed, but the definition of disturbance has been amended, as we discussed a few slides ago. As for number 4 is entirely new, and we also see the new term reconstruction being used, which we just went over. And then the bottom number has also been updated to note that a combination of 2, 3, and 4 that totals an area of 1/4 acre or more would be a major development. Major development also includes all developments that are a part of a common plan of development or sale, for example, phased residential development, that collectively or individually meet any one or more of paragraphs 1 through 5 above. Projects undertaken by any government agency that otherwise meet the definition of major development, but which do not require approval pursuant to the municipal land use law, are also considered major development. Now we are jumping to a later part of the rules, to NJAC 7:8 4.2, Municipal Stormwater Management Plan and Elements. And we're moving here because it relates to major development. In the previous version of the rules, the following text was included as part of NJAC 7:8 4.2a. For purposes of this subchapter, major development is limited to projects that ultimately disturb 1 or more acres of land. In the NJ Pact rules, this text has been removed. This change unifies the applicability of the stormwater management rules between the state and municipal level. And I just wanted to take a moment to emphasize the situation where a large lot is subdivided into several smaller individual lots, each less than 1 acre, and each sold and built upon separately. As the definition of development in the stormwater management rule states, subdivision in and of itself is a development. If the disturbance, the increase in regulated motor vehicle surface, the increase in regulated impervious surface, or the reconstruction of motor vehicle surface or impervious surface of each individual lot summed together meet the threshold of a major development, the subdivision itself is considered a major development, with each individual lot being subject to the requirements of a major development. The municipality or MS4 permittee must review the proposed development for those subdivided lots as a whole. Here are some additional terms relevant to understanding the design and performance standards. Infiltration is the permeation of stormwater into the soil by filtration. Groundwater recharge is precipitation that infiltrates into the soil and is not evapotranspired. Hydrograph, in the context of stormwater runoff analysis, is the graph depicting the flow of runoff versus the time passed at a specific point of analysis. And then design storms, which will be covered further on the next few slides, are theoretical storm events based on precipitation data with an average recurrence interval of 2, 10, and 100 years. So let's talk a little about design storms. Through a frequency analysis of rainfall depths and intensities from past precipitation events, the likelihood of a storm occurrence can be determined using probability analysis. However, a precipitation event being referred to as the X-year storm does not mean that this storm can only happen once every X number of years, nor does it preclude a larger storm event from also occurring that year. This table lists the probability of a particular storm occurrence and its corresponding chance of happening, expressed as a percentage in a single year. This is what is meant by the 2, 10, and 100-year design storms. The top storm listed in this table is the storm with a 1% chance of occurring in a given year. This is the 100-year storm. At the bottom of the table is the 2-year storm, meaning it has a 50% chance of happening in a given year. Now that we understand the likelihood of a design storm event occurring, keep in mind that one thing we do have is lots of data for these storms. County rainfall data is one source used in the calculations. The link for this data is shown in the header. When reviewing for a municipality, it's best to check the SEO to see if this data is used. However, this is only one of the sources allowed under the rules. The preferred choice for storm data can be found on the National Oceanic and Atmospheric Administration's, or NOAA's, National Weather Service, or NWS website. Click on New Jersey on the map to get started. I won't go through all the steps here. Instead, please read Chapter 5 of the New Jersey Best Management Practices Manual, which has the step-by-step directions and additional graphics. The stormwater management rules includes some additional criteria for the rainfall data used in stormwater runoff calculations. Studies by the Northeast Regional Climate Center and the DEP show that the 2, 10, and 100-year design storms for most counties have experienced increases in rainfall depth since 1999, when the original NOAA rainfall data was collected. So current precipitation adjustment factors and future precipitation change factors have been implemented and are applied to the 2, 10, and 100-year design storms in certain circumstances. The current precipitation adjustment factors found in Table 5-5 of the rules adjust the outdated rainfall data from 1999 to reflect what we are experiencing today. For example, the precipitation depth for the 10-year design storm for Hudson County, retrieved from the NOAA NWS website, should be multiplied by 1.05 to get the current 10-year design storm precipitation depth. The rainfall data applied with the current precipitation adjustment factors will be the current storm events in the rules regarding stormwater runoff calculations. The future precipitation change factors found in Table 5-6 of the rules update the rainfall data from 1999 to projected levels for the period between 2050 and 2099. For example, the precipitation depth for the 100-year design storm for Burlington County, retrieved from the NOAA NWS website, should be multiplied by 1.32 to get the projected 100-year design storm precipitation depth. The rainfall data applied with the future precipitation change factors will be the projected storm events in the rules regarding stormwater runoff calculations. Also note that within 5 years, beginning January 20th, 2026, and every 5 years thereafter, the department shall take action to determine whether the precipitation data incorporated into this chapter reflects the most current estimates for New Jersey, and shall, as necessary, amend this chapter accordingly. So the current and projected storm events will be mentioned several times throughout this presentation. So keep an eye out as we move on to the next section. In the last part of this presentation, we'll take a look at the design and performance standards in place to address the adverse impacts of land development that we discussed previously. These standards are found in the Stormwater Management Rule, Title 7, Chapter 8, or 7:8. As a reminder, here is an overview of those adverse effects of development previously discussed. Under the current rule, there is a requirement to mitigate these adverse impacts using green infrastructure, which acts to reproduce as closely as possible the natural hydrologic cycle, but more on that requirement later. We'll now address how we mitigate these effects in turn, beginning with the runoff quantity control standards in place to address the increase in volume and rate of stormwater runoff. So this is the text for the first runoff quantity control option. Note that the water droplet is the icon used in the BMP manual for this design and performance standard. In order to meet this quantity control option for a given design storm event, the post-construction runoff hydrographs for the current and projected 2, 10, and 100-year storm events must be bounded by and not cross at any point in time the pre-construction runoff hydrographs for these same storm events. And as mentioned earlier, the current 2, 10, and 100-year storm events are the rainfall data from NOAA applied with the current precipitation adjustment factors. And the projected 2, 10, and 100-year storm events are the rainfall data from NOAA applied with the future precipitation change factors. So an example scenario that meets this standard can be seen here, where the post-construction runoff hydrograph, shown here in gray, is contained entirely within the bounds of the pre-construction runoff hydrograph, shown in teal. And an example scenario that does not meet the standard can be seen here, where a shift in timing results in the post-construction runoff hydrograph exceeding the bounds defined by the pre-construction hydrograph. The second runoff quantity control option, seen here, is unlike the last quantity control option in that this option is a comparison of the current and projected peak flow rates for the pre and post construction hydrographs, and not a comparison over the entire hydrograph duration. Part of meeting this option is completing a detailed analysis of downstream flooding impacts and showing that no flooding will occur at or downstream of the site. However, the stormwater management rules adopted on January 20th, 2026 added subparagraph I, which is highlighted here. This subparagraph adds that in certain circumstances, if this demonstration is made, no analysis of downstream flooding impacts will be required. So let's rephrase that new subparagraph under option 2 here. Let's get a little deeper into it. No analysis of downstream flooding impacts will be required if the two open bullets shown on the slide apply, unless the review agency determines the project will result in increased flood damages downstream of the site. The open bullets are: there's no increase in the volume or peak runoff rates of stormwater leaving the site, and the change in timing of stormwater runoff is exclusively due to proposed BMPs to comply with the quality standards or the volumetric reduction standards. So for a redevelopment site, if there's no increase in runoff volume because the land cover remains the same and no increase in the peak flow rate, but the timing of discharge of the stormwater runoff changes because of installed BMPs for meeting the quality standards or the volumetric reduction standards, then there's no need to conduct this analysis. The third runoff quantity control option shown here, is similar to option 2 in that it is a comparison of the current and projected peak runoff rates for the pre- and post-construction hydrographs. But, unlike option 2, the analysis required is less detailed because the post-construction peak runoff rates for the 2, 10, and 100-year storm events are limited to 50, 75, and 80% respectively of the pre-construction peak runoff rates. This rate reduction is sufficient to demonstrate runoff quantity control. This is the option we see chosen most of the time. There is an exemption from the requirements at NJAC 7:8 5.6b. If stormwater runoff from a project discharges within a tidal flood hazard area, and it's clear that the increased volume of stormwater runoff will not lead to downstream flooding, then the site would be exempt from the runoff quantity control requirements of NJAC 7:8 5.6b. But it must be demonstrated that no downstream flooding would occur. Additionally, please note that this exemption does not apply to the volumetric reduction standard at NJAC 7:8 5.6d, which we will discuss next. The next few slides provide some of the rule text for this volumetric reduction standard at NJAC 7:8 5.6d. I will not read through all of this, but I encourage you to read through the full subsection in the rules carefully. I will leave each of these slides up for a little bit to give everyone a chance to read. All right, so we're just continuing through the volumetric reduction standard rule text. Again, I'll leave up this slide a little bit to give people a chance to read through. And here is NJAC 7:8 5.6d2, which also rolls over to the next slide. So I'll just give 10 seconds here. And here is the rest of NJAC 7:8 5.6d2. And we will show NJAC 7:8 5.6d3 later in Module 4, which only applies to public transportation entities in certain circumstances. So part of understanding the volumetric reduction standard is understanding the term retention. Retention is found multiple times in the volumetric reduction standard, and a definition of retention has been added to NJAC 7:8 1.2. Retention means retaining the stormwater runoff generated from development by infiltration, evapotranspiration, or reuse of stormwater runoff without the discharge of the stormwater runoff directly or indirectly to surface waters or to a treatment works. So now that we've looked over the volumetric reduction standards and understand the definition of retention, we can extract the key points from these standards. The key points here, as elsewhere in the presentation, are a summary and do not include the full requirements. Of course, the main reference for the requirements would be the full text of the stormwater management rules. So there are mainly two levels to the standards. The first level is found at NJAC 7:8 5.6 D1 and 2. Either D1 or D2 may be used to meet the standard, or they may be used in combination. So this slide focuses more on D1, and then D2 is on the next slide. Now D1 is the most basic, that BMPs from Table 5-1 or Table 5-2, which are found at NJC 7:8 5.2F, must be used to achieve retention of the water quality design storm on site. Now, if D1 is applied, but proven to be technically impracticable, or the stormwater should not be recharged because it is either from an area of high pollutant loading or industrial stormwater exposed to source material, and see NJC 7:8 5.4B3 for details on those terms. Then there is a second level where an extra option opens up to meet the standard using D1I1 through D1I2. D1I1 and 2 involve an analysis of the runoff peak flow rate and hydrograph duration for the water quality design storm for the site. The runoff peak flow rate and hydrograph duration will also be found for a drainage area equivalent to the size of the disturbed area of the major development with a woods cover type in good hydrologic condition and on hydrologic soil group D soil. The runoff peak flow rate and hydrograph duration will be compared between the two, and for the actual site, the peak flow rate shall be lower and the hydrograph duration should be longer when compared to the equivalent wooded area. With that explained, we then come to NJAC 7:8 5.6 D2. So as stated, 5.6 D2 can be used on its own or in combination with D1 above it. Under D2, the requirement may be met by removal of existing impervious surface totaling an area equal to or greater than the impervious surface within the disturbed portions of the major development site, and or retention of an equivalent or greater volume of stormwater runoff generated by the water quality design storm required pursuant to D1 at an off-site location. Now we'll move on to the water quality standards in place. In the previous version of the rules, the stormwater runoff quality standards were applicable when the major development results in an increase of 1/4 acre or more of regulated motor vehicle surface. The new rules, adopted on January 20th, 2026, now add that the reconstruction of 1/4 acre or more of motor vehicle surface will trigger the quality standards. As we touched on earlier in this presentation, reconstruction means the replacement, rebuilding, or restoration of a lawfully existing structure. Also, just to note that local SCOs might have a stricter threshold for meeting the water quality standards, as was mentioned in the last presentation. So definitely check the local SCO. When the water quality standards are triggered, stormwater management measures for water quality control are required. Why is that? Developed sites typically do not have the surface roughness to slow down runoff. This means there generally is not enough time for any pollutants to settle out, resulting in direct discharge to water bodies. The stormwater rule includes design and performance standards for water quality best management practices, or BMPs, and the rules focus on two pollutants: total suspended solids, or TSS, and nutrients. TSS includes sediment and other forms of pollutants that can be removed from stormwater through filtration. This is important because high TSS levels impair water bodies. Nutrients are generally a result of fertilizers and animal waste. The two nutrients of concern are phosphorus and nitrogen because they overstimulate plant growth in aquatic environments, which result in algal blooms and a reduction in dissolved oxygen concentration in water. Additionally, the amended rules include a new requirement at NJC 7:8 5.5J, stating that stormwater management measures shall be designed to incorporate any additional measures specified in a TMDL approved or established by the EPA unless otherwise required pursuant to NJAC 7:14A 25.6E. So let's expand on the TSS removal requirements when the water quality standards are to be met. So 95% TSS removal will be required for runoff from any new or reconstructed motor vehicle surface to be discharged within a 300-foot riparian zone as established by the Flood Hazard Area Control Act rules at NJC 7:13 4.1C1, or discharged into an existing or proposed stormwater conveyance system that ultimately discharges within a 300-foot riparian zone located within the same HUC 14 as the major development. Under number 2, 80% TSS removal is required for runoff from any new or reconstructed motor vehicle surface not covered at 1 above. And then under number 3, when the water quality treatment of a motor vehicle surface is modified or removed, if the motor vehicle surface is new or reconstructed, then 80% TSS removal would be required, or 95% TSS removal would be required if number 1 above applies. And then if the motor vehicle surface is not new or reconstructed, the existing TSS removal shall be maintained or increased. In order to meet the TSS removal requirements, stormwater runoff from the water quality design storm must be treated through the use of BMPs. The water quality design storm is a storm event with a custom rainfall intensity distribution that results in a total rainfall depth of 1.25 inches in 2 hours. The custom distribution can be found in the Stormwater Management Rule 7:8. The gold % sign is the icon used in the BMP manual for this design and performance standard. Some BMPs remove more TSS than others, so that each type may have its own value or even a range of TSS removal. The percentage identified in the BMP manual is only awarded to BMPs designed and constructed in accordance with the information in the manual. Also, if a BMP is not properly maintained, its ability to provide water quality treatment may be impaired. There is also an exemption from the requirement to reduce TSS. The requirement to reduce TSS does not apply to any stormwater runoff in a discharge regulated under a numeric effluent limitation for TSS imposed under the NJPTES rules. If there is a separate NJPTES permit, it has to cover the same area and the same runoff flow that would have been subject to the runoff quality standard. Now we'll move on to the third set of standards in place, which address the reduction in groundwater due to development. Earlier, we defined groundwater recharge as that portion of runoff that travels down past the root zone of plants. The stormwater rule provides two options for development. The full text of option 1 is posted here. To meet this option, a development must match the existing annual volume infiltrated on the pre-developed site. This option requires careful analysis, and unfortunately, we still see a lot of mistakes in the analyses performed or in the local review of calculations. The second option requires the designer calculate the increased runoff volume that will be produced by the development from the projected 2-year storm and infiltrate that amount. This generally requires a lot of stormwater be infiltrated, and this may not be easy to do if a project is going from a lot of vegetation to a lot of impervious cover, particularly if the soil was very well drained to start. And just to note, the projected 2-year storm event is the rainfall data for the 2-year storm from NOAA applied with the future precipitation change factor for the 2-year storm. Additionally, the brown shield is the icon used in the BMP manual for this design and performance standard. There is an exemption from the groundwater recharge requirement that is applicable to only previously developed portions within an urban redevelopment area. Previously developed is defined as areas devoid of woody vegetation, and for an area where woody vegetation has newly taken root, it's no longer considered developed. Just to note, we see a lot of compliance issues regarding the groundwater recharge standards, mainly due to improper soil testing, but that will be elaborated upon in a later presentation. The rules require that green infrastructure, or GI, BMPs be used to address the requirements for groundwater recharge, stormwater runoff quantity control, and stormwater runoff quality. Subsection 5.2 of the rules includes 3 tables listing BMPs and how they may be used to meet the design and performance standards. Since GI must be located close to the source of runoff, small-scale GI BMPs require limitations on the contributory drainage area. As noted in the last bullet on this slide, municipalities may approve alternative designs, but they must match the GI definition and follow other applicable limitations. Excuse me. Each of the tables identify columns indicating whether a BMP may be used to address stormwater runoff quality, quantity control, or groundwater recharge. Note that the fill color in each of the tables corresponds to the chapter of the title text in the BMP manual. Table 5-1 is green, corresponding with Chapter 9 of the BMP manual. Table 5-2 is blue, corresponding with Chapter 10. And Table 5-3 is black and gray, corresponding with Chapter 11. The last column is the separation required from the seasonal high water table, assuming the soil testing procedures in Chapter 12 of the BMP manual have been followed correctly. Note that Chapter 12 was formerly Appendix E in the BMP manual. Table 5-1 lists GI BMPs that may be used to meet the groundwater recharge, stormwater runoff quantity control, and stormwater runoff water quality design and performance standards, provided that the GIBMP is designed in accordance with the BMP manual. Some of the GIBMPs cannot receive runoff from motor vehicle surfaces and therefore do not address water quality, like cisterns and green roofs. Others do not attenuate the discharge of stormwater runoff from the 2, 10, and 100-year design storms, so they cannot meet the quantity control requirement, like dry wells. And there are certain MTDs with a vegetative or soil component that meet the GI definition. But not all MTDs are GI. A listing of MTDs that meet the definition of green infrastructure are NJCAT verified and certified by the department can be found on our website. Lastly, these systems are typically smaller in scale, and dry wells, GI MTDs, pervious paving systems, small-scale bioretention systems, small-scale sand filters, and small-scale infiltration basins all have a limited contributory drainage area that they can treat, as defined in NJAC 7:8 5.3b. BMPs in Table 5-2 can be used to address stormwater runoff quantity control. These can have drainage areas that are larger than the drainage areas of BMPs listed in Table 5-1. These BMPs may be used to meet water quality or recharge only if a waiver or variance is granted from NJAC 7:8 5.3. BMPs in Table 5-3 always require a waiver or variance from NJAC 7:8 5.3 before they can be used to meet any of the design and performance standards. It is not anticipated that these BMPs will be used much in the future because of what is required in order to grant a variance or in order to grant a waiver or approve a variance. As for some of the BMPs noted on this table, blue roofs don't have a reuse component, and extended detention basins are typically large and also require additional treatment to meet the water quality standards. The majority of manufactured treatment devices, or MTDs, currently do not have a soil or vegetative component, so they fall into this table. And subsurface gravel wetlands and wet ponds not designed with beneficial reuse are listed on this table. The regulations under subsection 5.2F specify that BMPs designed in accordance with the BMP manual are presumed capable of providing treatment necessary to meet the design and performance standards under the rules. However, anything that is not designed in accordance with the BMP manual is considered an alternative design. As with all major development projects, these alternative designs must be reviewed by the review agency, and in these cases, the DEP must be notified of the review agency's approval of the alternative design. The BMP manual is always updated to align with the current rule. Shown here is a snip from our BMP manual webpage listing out the chapters for specific BMPs. The BMPs listed under these chapters correspond to the BMPs listed in the tables under subsection 5.2 of the rule, with BMPs from chapters 9, 10, and 11 corresponding with BMPs from tables 5-1, 5-2, and 5-3 respectively. Next, we'll take a look at an example cover page from a BMP chapter. As we said, Chapter 9 contains all of the GI-BMPs listed in Table 5-1. Shown here is the cover page from Chapter 9.8, which is for small-scale infiltration basins. And it's a typical example of the chapters for the various BMPs listed in subsection 5.2 of the rules. At the top of the page is an introductory statement that provides an overview of how the BMP addresses pollutant removal and the rate at which it removes total suspended solids, or TSS, from stormwater runoff. The first table on the page is also an overview, and it identifies the design and performance standards of the rules for which the BMP can or cannot be used. This is where you see the icons we discussed earlier for each of the design and performance standards. If you're not familiar with the BMP, this is a good place to become acquainted with how the BMP complies with the rule requirements. In this case, the small-scale infiltration basin, when designed in accordance with all the design criteria in the chapter, is approved as a GI-BMP. It can be used to address stormwater runoff quantity control and designed as an online system. It can be used to meet the groundwater recharge requirement. And it has a TSS removal rate of 80%. The other tables below this first table, although not shown here, provide additional design criteria explained in the chapter. To reiterate, BMPs are awarded the TSS removal rate stated in the BMP manual only if they are designed in accordance with the BMP manual. That includes meeting the requirements for pre- and post-construction soil testing and a full maintenance plan, which Manesh will address next. A later presentation in Module 3, titled How to Review a Project, will elaborate on how to determine if a BMP meets the design and performance standards. Module 4 will also include further discussion on and examples of evaluating GI BMPs. In summary, in the first part of the presentation, we covered some of the adverse effects land development has on the hydrologic cycle, including increasing the rate and volume of stormwater runoff, degrading the quality of downstream water bodies, and depleting groundwater. In the final part of this presentation, we briefly covered the design and performance standards in place to mitigate some of the adverse effects of land development. Standards such as the three water quantity control options and the new volumetric reduction standard, the water quality requirement to remove 80% of total suspended solids or 95% for discharge into a riparian zone, and also the requirement to remove nutrients to the maximum extent feasible, the 2 groundwater recharge options, and the requirement to meet those 3 standards using green infrastructure. Thank you for your attention. Should you wish to contact me, here is my information. And I'll check in with our moderator, Chang-Yi. Do we have any questions that we'd like to address here, Chang-Yi?
We do have questions, but I think I can reply in chat. So I think it's already 1.5 hours into the presentation. So we will take a 10 minutes break. So please come back at 2:45. Thank you.
All right, hello everyone. Welcome back from your break. So far we have covered the history of stormwater regulations and the basics of the MS4 permit. You may recall from earlier the slide with the 5 post-construction stormwater management program requirements. One of them is to ensure the long-term operation and maintenance of BMPs. So let's get into that a little bit more. First, we'll look at why maintenance is so important. Second, we'll take a look at the historical background for the responsibility of ensuring maintenance. Then we'll get into the responsibilities of the Tier A municipality, public complex, or highway agency. And finally, we'll go over what should be in the maintenance plan and how to review it. So BMPs are pollutant removal mechanisms, as you know, and if they stop working according to their design, or if they even fail, there could be serious consequences that impact the environment. Since BMPs are designed to remove trash, debris, and sediment, they can often get clogged if maintenance is not performed. That means the drain time of a parking lot, for example, or whatever else is upstream may even be longer, which can cause flooding. It can also mean a basin takes longer to drain, which can lead to a possible creation of a mosquito breeding ground. Plus, they can attract unwanted wildlife or can even lead to complaints from the public. All of this is stuff we really want to try and avoid. So here are a couple examples of poorly maintained BMPs. The top image here has trash and vegetation collecting in it, so when another storm occurs, particulates will be transported downstream. And if you look at the bottom picture, the lawn depression, it's not draining properly. This inundation could result in bare soil areas and wind erosion when it dries. And if it doesn't drain, then algae could become established, and this could prevent, let's say, an infiltration basin from draining. Now, here are a couple examples of properly maintained BMPs. The top picture is of a rain garden, and the bottom picture is a green roof. Both are well maintained and clear of any debris and trash. There's no real visible signs of improper drainage that would compromise the BMP's functionality. So just some nice examples of maintenance here. So here's a question for all of you. Based on what you see here alone from the same site, does this look like a ponded infiltration basin or a constructive wetland? If you visited this site without knowing what was designed, you might think everything is okay. However, we have seen the plans and this was actually approved as an infiltration basin. Now, based on the presence of the wetland vegetation and the standing water, the right type of maintenance was obviously not performed and it became what you see now. At this point, the basin would need repairs or it may even need a retrofit. When BMPs are improperly maintained or neglected, the consequences can include water quality impairment, potential flooding issues, failing embankments, or the potential for safety concerns, erosion, health issues that could occur from, for example, like I said earlier, mosquitoes, or even financial impacts such as decreased property value. They can become a headache for a permittee, which is why proper maintenance needs to be performed. So now let's take a look at the historical background for performing maintenance. So the responsibility to perform maintenance is not a new requirement, as you can see from the 1990s Stormwater Control Ordinance model. The ordinance is designed to comply with the maintenance requirements in the stormwater management rules. The intent of this was to establish responsibility for continued maintenance, repair, and safety of stormwater management facilities before they're even constructed. The model ordinance that was issued in 1990 has required the responsible party to be the property owner of the project, a governmental entity, or other legally established entity, such as a homeowner association. It does not impose the responsibility on a homeowner of a single lot, unless the homeowner owns all of the lots in that development. So the responsible party should not be a single homeowner. The model stormwater control ordinance stated that an individual owner of a single lot in a development cannot be responsible for the maintenance of the stormwater management system of an entire development. The responsible party must be a homeowners association or similar permanent entity. We'll take a look at some examples of this a little later on in this presentation, so just keep that in mind. Well, then what are the permit requirements regarding maintenance of stormwater BMPs? As was previously mentioned, the Tier A, public complex, and highway agency permits require that the permittee ensure that adequate cleaning, long-term operation, and maintenance of BMPs take place. Under the Municipal Post-Construction Stormwater Management Program, you can start with an inspection program that includes notification of the responsible parties. A municipality can opt to enact penalty provisions into its ordinances as a step towards enforcing compliance, or they can even create a licensing program to offset inspection costs. The permit requirements for ensuring long-term cleaning, operation, and maintenance provided are divided into two classes based on ownership or operational status for the Tier A, public complex, and highway agency permit. The first group is facilities that are owned and operated by a municipality. They can be, for example, a town hall or some sort of library complex. The four elements required for this group are shown here, and they may be found in Part 4, Section C1 of the Tier A permit, Section C3 for the public complex permit, and Section C2 for the highway agency permit. Inspection and maintenance must follow the plans or be performed more frequently than stated on the plans. And a logbook needs to be maintained to show compliance with this section. If you are looking for more specifics, there are more details of this in the permit, which you can read further about. Continuing on, the permittee also must certify annually that these facilities are properly functioning. And lastly, improper functioning facilities where repairs were not made must be documented and prioritized, so a schedule must be maintained. The permit citations are in parentheses for the Tier A, public complexes, and the highway agency permits respectively. The second group consists of those facilities not owned or operated by the municipality. And examples of this can include a retail complex or even a housing development. The permit requirements are found in Part 4, Section C for facilities not owned or operated by the permittee. This is not a new requirement, and the way it is written is to clarify what has been required previously. The permittee is required to ensure maintenance is performed according to the plan, or even more frequently than the plan states. And a logbook must be maintained of the actions taken to enforce compliance, and these details are required. And again, for more information on the subject, please refer to your respective permit. Compliance with the permit requirement to ensure long-term cleaning, operation, and maintenance starts with the reviewer assessing the plans. Otherwise, the BMP may not even function as intended, or its performance may decline. Approving a weak maintenance plan will create potential problems for the permittee to enforce the performance of maintenance and may lead to the possibility of a permit violation. The review is a key element to ensuring long-term operation and maintenance. So for reference, the SEO includes the detailed requirements for a maintenance plan, and these are also found in the stormwater management rules at 7:8. The NJDEP BMP manual includes further details if you want to have further reference. If you're using the review checklist from the Tier A guidance document, the maintenance portion starts at the bottom of page 17. These are just cropped snapshots from the 2 pages just to get the information right here. Section C here applies to Tier A public and highway permits. Before the end of the presentation, I'll also show you some of the other documents available online that can assist you in the review of the maintenance plan for a project. There's also more information in Chapter 4.1 of the Tier A guidance for stormwater facilities maintenance. This is part of the table from that same chapter that lists the implementation schedule for these minimum standards for a Tier A MS4. Another part listing more of the minimum standards. I'm not going to read these to you, but they are certainly here to assist. And the final part with more minimum standards. The permit language is very similar for public complexes and highway agencies. We just have not prepared a guidance document for you for this module. So if you want to put things in perspective, an inadequate review can really wreck things for a project. The duties of these 3 parties that you see here on the slide, they have to really mesh together. So not requiring the details of the maintenance plan can push the burden onto the stormwater coordinator or the DPW facilities maintenance office, or it can even create an issue for DEP enforcement. So here's an example of a judgment that was issued against a municipality and the responsible party for not enforcing the stormwater management plan that was approved by the municipality. A lot of complaints were made because maintenance on an infiltration basin was not being properly performed. And this led to the basin clogging with odors and flooding for a neighbor, which is something that we really want to avoid happening. Since we would like to avoid such legal issues, let's talk about what should be in a maintenance plan so that we know what to look for when we review one. So I'm going to start with general information, show some examples of what a maintenance plan should not look like, and then get into more specifics. So the rules specify the maintenance plan must include details for the design that's shown on the construction plans, a list of tasks and the schedule for performing them, plus the cost estimates are required. The name and contact information for the responsible party must be clearly shown. This person or even party must perform both types of maintenance. So let's review what falls under preventative versus corrective maintenance. So let's talk about preventative first, which is the regular tasks that keep a BMP functioning as it was intended to be. So this can include quarterly inspections, grass cutting wherever it's appropriate, trash clearing, replacing vegetation that's failing to thrive, and even snow removal. Corrective actions are those that may be needed should failure start to occur, such as a periodic replacement of the sand bed and a sand filter. Or it could even be in response to a major event, such as a major rainstorm, a drought, car accident, or a high wind event, just to name a few. The plan must require that a logbook of all maintenance activities be kept so that the inspection can confirm this is being done. The inspection records must be reviewed annually, and they might even give clues that something is starting to fail or not work properly. The review should confirm that an annual evaluation of the plan is specified, and then during the inspection, the permittee should confirm that this is taking place. Chapter 8 of the BMP manual focuses on maintenance, in particular on page 2. On page 3 are other items for consideration and the procedures that must be followed. Retrofitting information can be found on the next page of chapter 8 as well, so you could take a further look into that over there. Chapters 9, 10, and 11 include specific maintenance details for each type of BMP. So for example, there are specific maintenance tasks associated with a small-scale bioretention system. You would have biweekly inspections and perimeter grass mowing. Those are just some. Another example is if you're doing GI with plantings, you would need to make sure that they are being watered, especially in the first year when maintenance would be a little higher. I mentioned procedures to be followed. One such procedure is the requirement to record on the deed information about the maintenance plan, and that identifies the responsible party, which would include the name, address, and phone number. The maintenance plan must be recorded with the parcel where the stormwater management measure is located. Any change in the responsible party information due, for example, to a change in property ownership, must also be recorded on the deed. The information must also be updated after project construction is completed. Now, let's look at some bad examples of some plans. If the stormwater management plan consists of a single sheet or is part of a plan sheet, this is an automatic red flag for the reviewer. Remember, the rules require schedules of the various types of maintenance tasks, an equipment list, and cost information, along with a logbook to record the actions that are performed. There's no way a completed record can be made on a plan sheet, nor would maintenance staff actually record observations and completed tasks here. So this would be an example of a very weak plan, and therefore the reviewer has the authority to request revisions so that the permittee can comply with the requirements of the permit. Now, imagine you are reviewing a 55-page maintenance plan for a constructed wetland, and you open the table of contents to see this. Now, you may think, well, they have a 55-page plan, they have preventative procedures, but if you look closely at the headings, A, grass cutting, F, mechanical components, and H, stormwater detention facility, this will indicate to you that the maintenance plan may not reflect the actual design and require some revisions. What this illustrates really is that the reviewer has a responsibility to check the details that are provided in the plan so that the permittee meets the permit requirement to ensure long-term operation and maintenance. In this case, this is an actual approved maintenance plan that had absolutely nothing to do with the constructed wetland that's shown on the approved plan. So think of it this way. A good maintenance plan is going to contain 3 essential pieces: information, planning, and education. From the maintenance plan, the reviewer and maintenance staff must be able to know what to look for, where the BMPs are, and how to get there, when and how to perform the maintenance tasks, and what training is needed to successfully follow this plan. Under the information section, a complete inventory of the various BMPs should be provided, including the type and location of the BMP, any outfalls, and the type and location of the flow control device. It's important to note, though, that the 2.5-inch orifice requirement has been removed. Now the focus is on the flow control device, which may take various forms. This device could be an open orifice that is visible above the ground, a perforated pipe, or other types of flow control mechanisms that are not easily seen on the surface of the BMP. Therefore, providing a clear indication of the location and type of the flow control device is an essential part of the BMP information. It should be easy to find the water surface elevation for normal conditions, as well as the design storms in relationship to visible elements in the BMP, if it stores or attenuates the discharge of stormwater. And in this case, the drain down time should also be included. If there is an infiltration component, what is the benchmark permeability rate so that the maintenance staff can check whether the system is failing? That should be known. And if there's a manufactured treatment device, what's the warranty, the owner's manual? Those should also be included. The second essential element is planning, which paints a complete picture of what should be done by maintenance personnel. We would not want someone to say, for example, mow a bioprotection system with a meadow, thinking it was an overgrown detention basin. Planning includes the schedule of tasks, the tools that are needed for each task, access information where sediment or trash is to be taken, and if it requires dewatering, where that is going to occur. If there is an internal component and it is destroyed by a large storm, maintenance staff should be able to correctly repair or replace it. I mentioned collected sediment. Planning includes how to transport it and what information, such as a receipt, must be retained. Planning includes the individual costs plus the annual cost for each task. So make sure this information is part of the maintenance plan when you complete a review. And the third element is education. Maintenance staff must be trained on safety measures, inspection methods, the various tasks, and the use of appropriate tools and equipment. Maintenance must also know what to record and where to file the records. Education includes knowing what records to keep. Always keep a backup of the records in another location. You may never know if the original records could be destroyed somehow. Now that the reviewer has checked the maintenance plan for accuracy, it's important to know whom this responsible party should be so that they can be contacted when an issue arises. For a public complex or highway agency, the permittee is this party. Under the TA permit, it could be different people or one or more organizations. Obviously, it should be the developer during construction or a public entity wherever it's appropriate. Transfer of the responsibility can be to an HOA in a residential development, an owner or a tenant in a non-residential development, another public agency, and only to a single homeowner or tenant in the event the individual is the sole owner of the entire residential development. If you take a look at 7:8-5.8C, it actually expressly forbids this. No homeowner can be held responsible for maintaining a basin in a residential development unless they own the entire development. So let's look at some examples of how we can apply this. So here we prepared some scenarios of who the responsible party should or shouldn't be that you may see when you review a project. So here's example one. A 5-lot subdivision has one BMP that is collecting stormwater runoff from all 5 lots. This BMP is on one of these 5 lots. Can that lot owner be the responsible party for the maintenance of this BMP? So think about that while I read example 2. A 5-lot subdivision has 5 BMPs. 1 BMP per lot. They only collect and treat runoff that's generated from their respective lot. Can the homeowners of each of these lots be the responsible party for each BMP that is in their own lot? So take another second here and just think about those. And the answer to both of these is actually the same. It is no. An individual homeowner cannot be the responsible party for the BMP that's located in their own lot or one separate lot unless the individual homeowner owns all of the lots. Now let's look at a third example. Development of one lot that doesn't propose any subdivision and is a major development has one singular homeowner. Can this homeowner be responsible for maintenance of a BMP that is proposed for this development? And think about that for a couple seconds. And the answer to this one is actually yes. So like we said earlier, an individual homeowner can be the responsible party for the BMP that's located in their own lot if they are the sole owner of the entire development. The difference between this example and example 1 and 2 is that in this one, the homeowner owns the entire development. So that's the big key about this subject. They must own the entire development to be the responsible party. All right, moving on. As we have learned earlier, a good maintenance plan is going to include a lot of information. For this reason, my colleague created various templates for use for a designer. These templates can be customized. They're also created in such a way that they can be used as a teaching tool for reviewers and maintenance inspectors alike. Here is a representative sample of the various templates that could be used in a project. Anyone can go to the department's website, and there you'll click on maintenance guidance. And at the top of the page is a brief introductory video, followed by a template of a maintenance plan. And below that is the field manual section. And here's an example of the field manual for a surface infiltration basin. Each BMP should have its own field manual because each of them has different functions and components that need to be inspected and maintained. The field manual templates include the components as shown on the left. They are the BMP overview, basic design information, visual aid for stormwater basin inspection, any reference documents, inspection checklists and maintenance actions, preventative maintenance record, and corrective maintenance record. The designer modifies the contents of the field manual template with the design information of the BMPs that are incorporated into the development. The reviewer makes sure the information is correct, and the responsible party follows the field manual to perform maintenance. The municipality, depending on the ownership status, will then follow the permit requirements to ensure maintenance is performed. The reviewer should also make sure the inspection checklist has been customized to match design features on the construction plan and in the stormwater report. This is a partial screen capture of the infiltration basin inspection checklist log that can be found online in the maintenance guidance section of the Tier A guidance document. Another partial screen capture, and this is of the infiltration basin preventative maintenance. Logbooks are also available on the webpage for recording both preventative and corrective maintenance tasks that are performed by field personnel under the heading of maintenance logs and inspection records. So these are what the maintenance staff may look at during periodic checkups of the maintenance records. For our municipal reviewers, if a private party applicant is missing logbooks, show them where to find the templates and have them use them to make it easier on the municipal inspectors. So this can all be found at the link at the top. Here's a screenshot of the maintenance webpage. Definitely check it out if you haven't seen it. It's very, very useful, highly recommended by all of us, and it spells things out very well, very clear, with detail on what you need to do if you're having trouble and need help, or even if you have questions on what to do, you should be able to find answers there. To sum things up, without proper long-term maintenance, the BMPs may not continue to function as designed, resulting in impacts to the environment. The permittee is required to ensure long-term operation and that maintenance is being performed. A municipality may institute measures to facilitate these efforts. The first step towards meeting this permit requirement is a thorough review of the maintenance plan submitted with a development or redevelopment application. We also reviewed the 3 key elements of the maintenance plan, and those are information, planning, and education. And you've all seen where guidance and field manual templates may be found on our website. So again, please use those as a reference if you need help and or need any type of answer. So thank you again for your attention. Here's how you can contact me. Before I turn it over to our next presenter, I want to remind you that you can type out questions through the chat and staff will be getting to them shortly. Or if you always have an email for me, I'm glad to take emails as well. And with that, I want to ask Changyi, is there anything pressing that we need to answer right now?
No, so we can continue the course. Thank you.
Great, thank you. So up next is Dr. Richard McGee from the New Jersey Corporation for Advanced Technology, who will discuss the NJCAT DEP partnership for the verification and certification of manufactured treatment devices. So good afternoon, Dr. McGee.
Hi, this is Lisa. While Dr. McGee gets his microphone set up, I want to thank you, Manesh. And so, as we said, Dr. McGee is from the New Jersey Corporation for Advanced Technology, and he will discuss the NJCAT DEP partnership for the verification and certification of manufactured treatment devices. Dr. McGee, are you ready?
I just allowed Dr. McGee's microphone, so you should be able to unmute Dr. McGee.
Let's try one more time, Dr. McGee.
Should be able to unmute in the top right. It might not have worked before, but it should be enabled now.
Okay.
There we go.
All right, we're all
Welcome.
set. Good. Okay. Again, good afternoon to everybody. I want to stress in the first slide very quickly that this is a real partnership between DEP and NJCAT. Next slide. Try to move us along. I want to talk a little bit about the history behind NJCAT. I want to talk about the role of MTDs. We already heard about some of that in meeting NJAC. I want to talk specifically about the verification program. I just want to give you some examples of verified certified technologies. Then I want to focus heavily on the misuse of certifications outside NJDP and how you have to be careful when people submit plans that they're not misusing the certification. And then I want to talk about where the program is and where I see it moving forward. Next slide. Okay, this whole initiative began back in the 208th legislature, beginning that was July 1999 to 2000. So effectively, NJCAT has been around for about 25 years. And it was at a legislative decide that we want to encourage new businesses to remain in the state and particularly facilitate development and commercialization of technology-based environmental energy products. The program then became formally established the same year, and the legislature appropriated $95,000 to implement the program. I'm proud to say that the program has since been sustained by manufacturers' fees to administer the program. So the only cost to the department, which is not insignificant,
Excuse me.
Chang Hai would know that, is preparing the certification letters. Next slide. Anyway, this all got brought together in something called the EETV, which is basically the Environmental Energy and Environmental Technology Act, and it basically laid out the roles of the state of New Jersey, DEP, and NJCAT to administer this program. Next slide. Then things got finalized in June of 2000, where NJCAT and NJDEP signed a basically memorandum of agreement of how we would develop this partnership. It's been a great partnership. It allows for a process to achieve clarification of any DEP and NJCAT interpretations of laws, rules, regulations. It requires DEP to consult and work with NJCAT to develop performance and verification procedures, processes, and protocols, and we have documents in place that do that. There are also that partnerships determine the application and use of certain innovative environmental energy technologies, and obviously they have to fit your existing structure as far as regulation is concerned, and therefore not every manufactured treatment device that someone is developing will in fact fit into New Jersey. And we'll talk a little bit about that. Anyway, we're required to promote awareness of any ETV program to entities with technologies that are likely to be eligible for performance evaluation and verification. And that, at this point, as I'm going to say, occurs with very little effort on our part because the program is well established. Next slide. Okay, you've already heard about that. States have adopted strategies and management rules to address the adverse impacts of stormwater runoff, and they have low impact development strategies, both structural and non-structural, to carry out this thing. And they all get lumped into what we've just been hearing a lot about, the best management practice, or BMP manual. Next slide. Okay, so now we're moving. Manufactured treatment devices are simply a subset of BMPs. They're proprietary, prefabricated stormwater treatment systems that rely on a variety of mechanisms to remove pollutants from stormwater runoff. And physics is physics, so they can use settling, if you went back to your Stokes law, and fluid filtration through various media, organic and inorganic. We use vortex separation. In some cases, you can use vegetation. So others have that use membranes and any appropriate technology to remove. Unfortunately, right now, because the way the program is set up, the only pollutants that we address are TSS, total suspended solids. So the remainder of the presentation will be on MTDs. Next slide. Okay, as you know, major development projects to remove 80%. I saw a number 95%. I have not seen that before, but maybe that is the case. Your NJAC 7 requires the use of green infrastructure that manage stormwater. That is a restriction that was put in about 5 years ago, and it has changed the whole nature of the innovation and work that's going on in industry to be able to come up with a BMP that is in fact a manufactured, but also consistent with your BMPs. And we've already heard the earlier presentations. That means it's got to treat stormwater through infiltration into the subsoil. And as I've learned, as I tell the people come in, that means 100%, or it must be filtration by vegetation or soil. As we've already heard, the NJAC 78 provides removal rates, and that's part of what our job is. And the key difference, and this is a very important distinction that many states outside New Jersey do not understand. NJCAT verifies, and that verification against the performance against well-defined test protocols that have been jointly developed by DEP and NJCAT. And then after we certify that it's, after we attest to DEP that the protocol has been met or exceeded, our reports go out to the world. That means anybody can comment on it. I probably have a list of about 45 companies or people who can read them. They have a 30-day period to comment on it. And the role of NJCAT, or my role along the way, is to see to it that every comment has been addressed. And that can be, in some cases, an inadequate maintenance manual. And I just have one right now that they've redone their maintenance manual, and the comments were right on, and then a few other things as well to clarify certain points. Also, as we've been involved in this process, we've also found that no matter how good a protocol you put together, industry almost learns how to game the system. So we've had to, first of all, in the early days of this program, the department was interested in field verifications, and Mother Nature does not cooperate, and it's very hard to compare one technology to another. We then went to a laboratory-based system in 2013, and we found out again that the industry learned to game part of the test by backing up sediment in the inlet pipe and taking credit for that as a removal rate, and which was not being removed by the device. But we've got that all under control. We now have a new protocol that was put in 2021, finalized in 2023. And so it's been an entirely evolving program. Next slide. Okay, so again, we conduct an independent third-party evaluation to verify the performance claims of the IEETs. And this is always against a protocol that has been jointly developed between the department and JCAT. Very proud of the fact that the program has strong national and international recognition. It's almost like the UL in the stormwater area. Almost every state is using the certified or verified and certified technologies to permit technologies in their field. International, currently working with a company in Australia. We've already done one other in Australia. I've done it with a company in Germany, and because they realize the value of having this verification certification. As I already mentioned, they're evaluated against NJDP test protocols. The latest came 2021, updated 2023, and filtration 2022 to 2023. So stormwater MTDs are NJCAT and NJDP verified and NJDP first certified are the only MTDs that can be used to satisfy New Jersey stormwater management rules. To give you an idea what manufacturers have to choose from, there are currently 11 hydrodynamic separators that are both verified and certified, 15 filtration devices, 16 green structures, and 2 are under public review. Going back, since I last made this presentation last fall, we've added 3 new hydrodynamic separators. This is industry is innovating. They're finding different ways, and they only have a few tools to work with based on the physics. So they've learned ways to increase the detention time of the particles in the device. I've seen no increase in filtration devices. That's the same number. And I think the feeling there is that many municipalities are moving away from filtration devices because of the maintenance. We just had a good thing on maintenance. And green infrastructure is growing very rapidly, 2 to 3 a year. And this is all basically due to the green infrastructure requirements that New Jersey put in about 5 years ago. So it's exciting to see what's coming in. And as I mentioned, public review, every report that NJCAT does has to be subject to public review, and all comments need to be resolved on the report before I can go forward to the department and say that we've met or exceeded the protocol. Next slide. Very quickly, I want to go through some ideas of some of the technologies that have been in the past. Some are not, I don't think, being used that much anymore, and you'll see why. This is a case where you've got a debris separation screen, and you've got access hatches obviously carried out. And basically, as the fluid goes, as the stormwater goes through, you get settling underneath into the sumps. Now, that's not very sophisticated because it's simply due to Stokes' law settling. Next slide may give you a better idea of how it works. Next slide. You'll see as the flow comes in, there's a splitter up front which directs the debris trash on top of the screens. The stuff that goes through that's also screened openings goes down the center, and that's where it drops out into the sumps below, and then it joins together and goes on the outside. Now, I want to make a point here. It's an important point. You notice that this MTD would not work unless what? Unless the inlet and the outlet are aligned in the same direction. Why do I say that? Because I understand there's a recent technology that's still on a plan up for bids in New Jersey. And how do I know that? Because the manufacturers police it like crazy. And they have a different scheme than the technology was verified. So it's important that everything has to match to make the verification and certification meaningful. Next slide. This is an idea in a manhole. In comes the flow of the inlet pipe. It hits a flow splitter. Stuff that is oil and floatables get caught on the skimmer above. And then we goes through and obviously an access riser to be able to clean things out, and through an outward weir. You'll see better on the next slide how this works. It comes in, you see how it gets split in the front there. It then develops a vortex motion, which basically retains the stormwater for a longer period of time, enhancing the settlement out, and then goes to the outlet pipe, and it goes through the outlet thing like that. Again, inlet outlet must be aligned on 180 degrees, or it's not going to work. Next slide. I told you there are perk filters. This is one put out by Oldcastle Infrastructure. Fluid comes in at an inlet. There's a bypass wear pipe, which means if the fluid goes above that level, it will bypass the treatment chamber down through that pipe, and therefore it will then match the outlet as well. So that would be untreated stormwater. And obviously the performance of this device had to treat up to a level that they avoided bypass or it had to be included. But if you think about most filter type devices, they try to build in settling, and you notice those two canisters, so to speak, are sitting in a vault. So therefore, there is some sediment that gets dropped down to the bottom, fills up at the bottom, and the rest of it will then come in radially through the devices, and then eventually go down to the outside, and you'll go through the outlet. Again, 180-degree inlet-outlet device. Next slide. This is Context Filtera high-capacity device. It comes in here. You see you've got a kind of curb in here, so it's an outside curb. It goes in, it distributes there. Here you see it's one tree, and then there's a filter media underneath there. Now to get GI credit for it, which they do have, that would have to be a soil media. In most cases, when people use soil, they also use vegetation at the same time, just because it's more aesthetically pleasing. There is one technology in the hopper, so to speak. It's Aqua Shield's aquaponics, which only uses vegetation. Next slide. And finally, here's one where they use a different technique. Come in here and they have called modular wetlands. Stuff goes down in between and fluid goes through radially from the outside in, goes to the outlet pipe on the bottom. Meanwhile, anything that settles out on the floor, and it's in the sump. So that's just some idea of some of the different schemes that people have come up with. Okay, next slide. Okay, misuse of certifications. This you got to pay attention to. I'm sure you've been paying attention anyway. Not all NJCAT verified stormwater technologies are NDP certified. And the biggest difference is there are many states that don't want to go to filters, do not believe as much in green structures, but they say, look, we have a pretty stringent particle size distribution. D50 is going to be less than 75 microns, which means that 50% of the pest particles come in TSS is less than 75 microns. If you go to a larger particle size, which some states are willing to accept, it's called OK 110, where it's more like at a D50 of 110 to 150, 120 usually, you can obviously get higher performance. And in any event, it occurs like almost exclusively with HDS separators. And so NJCAT has taken the position that since there's value for it, that we will certify it against the same test protocols, verify it, I apologize, against the same test protocol that we use for NJDEP, but we caveat the report, and therefore it is only basically a verified, it's not a verified certified. Of the units of the currently certified stormwater technology, as I pointed out, the largest category are GI. and that number has grown 2 to 3 a year. Now, I've tried to make this point along, so I'm going to make it again. Only the ADS MTD configuration that was tested has been NJDEP certified. And you will find sometime that manufacturers will put on plans coming in inlet outlet configuration that's not 180 degrees apart, multiple inlet pipes. Sometimes they have two coming in, or they may go to a great inlet. Okay, none of those are certified, nor are they therefore usable in New Jersey. So it's imperative as reviewers that you check the configuration shown on the plans, that it matches the configuration tested as noted in the NJDEP certification letter and illustrated in the NJCAT verification report. Next slide. Again, another misuse of the certifications is whether they can be used inline or offline. And if you look at the certification letter, you'll see here's an example that it can only be used offline. And there are ways of getting for HDS systems to get inline approval, but you have to test at greater than 200% of your manufacturer treatment rate to show that you're not going to scour out sediment that's already been collected. Okay, next slide. All right, so the program continues to evolve. We've added, if you go to our webpage, is good. We've expanded and added explanatory text, and you'll see under laboratory verified and NJDEP certified the three different categories. And also you can then link those categories to, and we have a link to the DEP page. We have some that are laboratory verified, and I've told you why the most public. I owe us a couple are out for public review, and we have in the past, again, because we worked with DEP, we've had some verified, certified energy technologies that in one was for small scale cogeneration systems. There was a lot of discussion when we went from the 213 protocol to the 2021, 2023 protocols. What do you do with those technologies that had been verified and certified under the old protocol? And so we've archived those. We've caveated that with the thing that they're no longer valid. And and we did some field verifications in the beginning, but I never felt comfortable with that. And that's where the department agreed to go to laboratory verified. Next slide. So where are we going as we move forward? We're managing the implementation of the new HDS protocol. The big thing is no longer a technology is going to get credit for depositing sedimentation inlet pipe. And it's interesting to note that we have a provision in the new protocol that you can test different inlet angles than the 180 in, 180 out. And I've got a couple companies that are looking at that, and others, in fact, one has actually gotten approved, and another one that's looking at a great inlet and others, because the nature of the internal design is such that it can do that. Many of the HD technologies that were sunset decided not to retest under the new protocol because their performance would not match it. And therefore, I've seen what I call active HDS technology development and innovation underway. And that was one of the charges we had to promote innovation. And no matter how good you write a protocol, there's always questions about, did we clarify things well enough? So we're developing a clarification document. There's a lot of interest in obviously MTDs. So ASTM has established a new committee, and they're developing ASTM standards, which are based on the NJDEP laboratory test protocols. And the transition from the old Verify to the new ones was transitioned in 2023. What that means is some people might argue that they have a technology that was on a plan that went back before the new protocols came in. And we decided, okay, we would give them a certain amount of time and then they would all sunset. So that transition has occurred. And there's one other, I'm going to call it a competing program, and that's industry has put together a stormwater testing and evaluation for products and practices. I don't think it's developed a lot of traction, and it's because it's heavily manufacturer driven. Only those who pay dues get to vote. The NJDEP, NJCAT process is open to anybody who wants to comment. So I think we get a better product, but I'm probably biased. And I think, Lisa, I think that's it.
I think so.
So I think if there are any questions, Chang-ai, any?
Hi, Dr. McGee. Yeah, I don't see any question posted in the chat. So I think we are good. Thank you for your presentation and be with us. Thank you very much.
Okay, there is an interesting question that just came up. I saw it.
Oh, okay. Yeah, just come up.
Is there any protocol for nutrients and phosphorus? And the answer is no. I would like to see that because as you pointed out very early on, that's important. Right now, we don't have any. So that might be something that we challenge DEP to say, are you interested in it? And if so, NJCAT would put it, and we would develop a test protocol to do it. It's interesting if industry tries to give you data, unless you're very savvy, and I'm not saying you're not savvy, they will try to pull wool over your eyes. And I'll end with this point. Years ago, when I got involved in this program, and I have been involved since its early stages, first as technical director and now the executive director, that someone, it was a Canadian company, came in and say, hey, this technology removes 94% TSS. And I've never seen one. It was a hydrodynamic separator. And I went back through the data and I found out that it was never stressed and the field data they had at higher than 4% of what it was rated at. And it doesn't surprise me you get 94% if the water's trickling in there because you got more time for settling. So you have to be very, very careful. And particularly it's not so much, I think, the lead company, but some of the, shall I say, the salesmen or the reps that come in are going to push. So again, be careful, go back and look at the reports, go look at the certification letters, and good luck.
Okay, thank you, Dr. McGee. We're on a little bit of a crush for time, so I'm going to move ahead to the next presentation. But thank you, as always, for all the information. We really appreciate it.
Okay, well, I appreciate the opportunity. And I thought I tried to talk pretty quick, but who knows?
You did. It's okay.
Okay.
All right. So folks, we rely on quizzes to indicate your attendance and to let us know how well we did with the instruction. We're not going to score you individually, but we use the overall class average to help us figure out where we did good or did well and where we didn't. So I need to show you real quick for those of you who don't know how to find the quizzes. The first way to access it is by smartphone, and I will momentarily display a QR code. And you can focus your camera on it and go there. Or if you're going to open your quiz on your computer from the hidden training page, you want to make sure you're not on the public facing one. All right. And you probably want to open that in another window or tab so you're not booted out of the meeting. All right. So the quiz link is going in the chat, and I'll just run through this real quick. Okay, so if you're on the page, all right, that has groundwater mounting over here, you're in the public facing page. This was last fall's layout. All right, that's on the public one. This down here is the correct page. Okay, so make sure you're on the correct page. All right, and here's the QR code. If you want to point your smartphone camera here, it will put up a link to SurveyMonkey. Do that in a new tab or window, you know, so that you're not accidentally kicked out of the meeting. Okay. Or if you're on this page, just go down here. Quiz 1 is the only one that is now open. You just click on that and it'll take you over to SurveyMonkey. All right. Now, you've got this information. And like I said, we're a little short for time. So, all right, I want you to take the quiz. This is what the URL is. And we are going to leave the quiz open till exactly 4:15 and then shut it down. So you have to be done by 4:15. And because we're short for time, we will do the review, which counts for credit, by the way, on Thursday when we meet. All right, so make sure you answer every question. You can't skip ahead without, you know, and leave a question unanswered. And you have to click done at the end. You can only take it once and only during this time. All right, so later on, we will review on Thursday the answers. All right, so with that, let me just see. Yeah, you have a problem while you're taking the quiz, you have to email us at that time and use this email address. Don't use the old DWQ. That one's being retired. Put this one in your favorite. Okay, so you got the link, you get the QR code, and if you have a problem, email me now. And go. And for those of you who don't have access to the chat, when you're done taking the quiz, you are dismissed. Please just do your best to answer it correctly so we get a good grasp of how well we did at teaching the information. Thanks, everyone. Okay, everyone, when you're done with the quiz, you're free to go. I will send out the invite for module 2 tomorrow. So please put a hold on your calendar for Thursday, and then you'll get the invite. And if it's not in your inbox, you can check your calendar, check your spam folder, or if you have it, you're recently deleted. Don't know why it goes there. But if none of that works, then reach out to us through the Stormwater Management Rules account that you see on the screen so that we can get you situated before the training commences. Thank you, everyone.